Release 2012 free response question number 6, part C. Here's our question. We need to find the acceleration of the particle at time t. And then a second part is the speed of the particle increasing, decreasing, or neither at time t equals 4. And we need to justify this. We need to explain our reasoning. So here's our given velocity. We know that acceleration we're going to find by acceleration is the derivative of the velocity. But then we'll have to think carefully about speed increasing or decreasing, because acceleration and the increase and decrease of speed are not always so obvious how they're related. So we'll talk a little bit about that. So first, let's find the acceleration of the particle at time t. That's going to be an easy point for us to get as long as we can do a derivative. It's really a first semester question. So we have v of t is equal to cosine of pi over 6 t. So all we need to know is that the velocity is equal to the, what we need to know is that the acceleration is equal to the derivative of the velocity. And it's conceivable we will get a point just for writing that, just for saying that acceleration is the derivative of velocity, because we've indicated that we understand that. Now we're going to go through and actually find that derivative. So the derivative of this function, well, derivative of cosine is negative sine. This is a chain rule because there's an inside function here. This pi over 6t is a function inside our cosine. So we're going to do our chain rule by keeping the inside function the same and then multiplying times the derivative of the inside function. Well, the inside function is pi over 6t, and the derivative of that, which we usually call g prime, or maybe we'll call it u prime, is pi over 6. So that is the acceleration. So now we've done this first part. We have determined the acceleration of the particle at time t. They didn't give us a specific time, so we just say it's this. We could clean that up a little bit and say a of t is equal to negative pi over 6 sine of pi over 6 t. But this is fine just the way we wrote it here. All right, second part asks us if the speed of the particle is increasing or decreasing. And that sounds like an easy question, but you have to understand how velocity and acceleration work together to change the speed. So first of all, suppose I have a velocity that is positive. So that means the particle is moving to the right. And let's say I also have an acceleration that's positive. So my acceleration is also going to the right. So if my velocity is to the right and my acceleration is to the right, then the velocity and acceleration are working together and they're pushing that object farther and faster to the right. Therefore, my speed increases. So that's not surprising that when the acceleration is positive, the speed increases. Also, if the velocity is positive and the acceleration is negative, so now the acceleration is going this way. This is our acceleration less than 0. Now the acceleration is pushing against the velocity, so that's going to cause the particle to slow down. So our speed is decreasing. So far it looks like whenever the acceleration is positive, the speed is increasing. Whenever the acceleration is negative, the speed is decreasing. But that's not the whole story, because suppose the velocity is decreasing, so the velocity is negative. So if the velocity is negative, that means the particle is now moving to the left. And now let's also suppose that the acceleration is positive. Then the velocity is to the left, but the acceleration is pushing against it to the right. So this object continues moving to the left, but it's slowing down. So it's going faster and then slower. So this object is slowing down. The speed is decreasing even though the acceleration was positive, because the velocity was negative. So the velocity and acceleration were opposite to each other, and that's what causes it to slow down. So now let's say the velocity is negative. So that means, again, we're going to the left, because whenever the velocity is negative, we're going to the left. But now let's say the acceleration is negative. Now the particle is moving merrily to the left, and the acceleration is pushing it even faster to the left. So this particle is going to go to the left faster and faster and faster, and as a result, our speed will increase. So that's speed increasing. So what we want to notice about the pattern here is that whenever the acceleration and the velocity are opposite to each other, like here. The acceleration is negative, velocity is positive, acceleration is positive, velocity is negative. Whenever the acceleration and velocity have opposite sign, then that means our speed is decreasing. And whenever velocity and acceleration have the same sign, velocity and acceleration have the same sign, then speed is increasing. All right, so this is the critical information here, that when acceleration and velocity have the opposite sign, speed is decreasing. When velocity and acceleration have the same sign, speed is increasing. And that's going to be a really important thing to bear in mind as you do questions about whether the speed is increasing or decreasing. So now we have to think about our particle with its acceleration, where we know what the velocity is and we know what the acceleration is, and we've been asked at time t equals 4, is the speed of the particle increasing, decreasing, or neither? So we will look at what the velocity and acceleration are and just compare their signs. So we know that the velocity is given by cosine of pi over 6t, and we figured out that the acceleration was given by negative pi over 6 sine of pi over 6 t. And we need to determine whether these things are positive or negative at 4. So our velocity of 4 is cosine of pi over 6 times 4. So that's equal to the cosine of 2 pi over 3. And now I need to determine if that's positive or negative. So I'll think about my unit circle. I'll think about where 2 pi over 3 is. It's right there. I'll think about the fact that cosine is the x-coordinate, and the x-coordinate is negative here. So I'm going to say that that velocity is less than 0. Notice I don't have to say what the cosine of 2 pi over 3 is. You know it's negative 1/2, but you don't have to say that. The only thing that matters here is that it was negative. So we'll say that the cosine of 2 pi over 3 was less than 0. Now we'll say what the acceleration at 4 is. So the acceleration at 4 is negative pi over 6 sine pi over 6 times 4. So that's negative pi over 6 sine of 2 pi over 3. Now, negative pi over 6 is negative, and sine 2 pi over 3, again thinking about my unit circle, sine is the y-coordinate, and that's positive, so that's positive. So my acceleration at time t equals 4 consists of a negative times a positive and is therefore negative. So the critical things here is I'm saying at time t equals 4, the velocity is negative and the acceleration is negative. Notice again, I don't have to work out what this is. I just have to say that it's negative, and I have to be right about that. Then I'm going to say the velocity and acceleration, I have the same sign. They're both negative. So you're going to say, since velocity and acceleration have the same sign, the speed is increasing. And that's our conclusion to number 6. That question had a couple of parts, so let's make sure we answered them both. It said, find the acceleration of the particle at time t, and we found the acceleration of the particle at time t. It was a of t equals negative pi over 6 sine pi over 6t. And it says, is the speed of the particle increasing, decreasing, or neither? We said the speed is increasing. that's good enough for that one.